Okay, now let's take a look at scatter plots, which is just a graph with plotted points, usually taken from a survey. And you can see that they are just kind of scattered about, and you do not connect the points in a scatter plot. Now, I know you can see some linear graphs, and those are the lines of best fit, which is the linear model we'll use to make predictions. Let's take a look at the correlation, starting with a graph to the left. We can see that these plotted points, these data points, are clustered together, and as we go left, it seems as the dots are increasing, so that means it is positive. And because these points are clustered close together, we say it's a strong positive. In the second example, we can see a trend as we go left. Our points seem to be going up, but they're not as close together, so we call it weak, but it's still positive. Then we can have a strong negative where our data points seem to be going down. As the x values increase, the y values decrease. So this is negative, and they're clustered close together, so it's a strong negative. We can see in the fourth graph that as the x values increase, the y values decrease, creating a negative correlation, but they're not close together, so we say that is a weak negative. Then you can have a situation where the x variable category has no effect on your output. So there's no correlation. They're just scattered about. There's no trend. They're neither going up nor down. So that will be no correlation. So let's take a look at a graph in which a survey has been taken, and it's the fuel gauge. So we can see with different vehicles, the total amount of fuel depends on the type of vehicle you have. But we do know that no matter what vehicle you have, whether it holds 40 gallons or 30 to begin with, as you drive, the fuel gauge is going to decrease. So we can see as the hours of driving any vehicle, the gas gauge is going to decrease. The amount of fuel in our vehicle goes down. We can see that the line of best fit has already been plotted for us. So when we do these, I'm going to suggest the 2 points to use to write a linear model that represents how much fuel in your vehicle over a given amount of time driving it. We're going to use y equals mx plus b. So let's just take a look. We could use the line itself, or we can take 2 plotted points, and I usually take one from the end on each end, and usually one kind of maybe just a little above the line of best fit, and then maybe one right below it. So let's take these 2 points and write our slope. So let's do the slope first. So let's take a look at the 2 points. This point is going to be 0, 40, and this point here looks like 8, 5. Now let's find the slope. y2 minus y1 over x2 minus x1. This is going to give us negative 35 over 8. And let's just write this as a decimal. This is going to be 4.375, and it's negative. And I'm just going to write it as this. You may be told to round to the nearest whole number, tenth, whatever. But this is what I got in my calculator. So the more precise you are, the more accurate your data is. Now, we can see these plotted points, but we can use this slope to help write our equation. And then we can make predictions. So let's find the y-intercept. We could kind of eyeball it here and say that the y-intercept is 40. But then we have this one that kind of offsets that, so it's a little bit underneath 40. So I'm going to just say, let's go, if this is 35, let's say this is 38. So I'm going to say our initial value is 0,38. Now we can put these together and we have our slope times x plus the initial value. So x represents hours of driving, so we can see about how much gas we will have left in our tank depending on how many hours we drive. So we start out with about 38 gallons, and then each hour we lose 4.375 gallons of gas. So let's make a prediction and see, using our linear model, let's see in 5 hours how much fuel is in the tank. So Y is total fuel, not used, but total fuel in the tank. And X is hours of driving, so hours. So we're going to use our calculator and we're going to multiply. So we have -4 times 5. And then don't forget your initial amount of fuel that you have. So Y is going to equal 16.125. And one of the questions is there a correlation? And yes, there's a correlation between hours of driving and gallons of fuel in your tank. As hours of driving increase, the gallons decrease. So this has and it looks pretty strong to me, a strong negative correlation. Let's take a look at one more. This is hours of basketball practice and how many points folks make in a game. So first of all, is there a correlation? You always ask, as the X's increase, what happens to the output? So as the more hours you practice, you can see that the number of points that you make in a game goes up. And these points look pretty close together. So I'm going to say this has a strong positive correlation. Now, let's pick 2 points and write our equation. This looks like a good point here. And then let's just go ahead and use this point here. So to find the slope, we're going to use point 2, 0. And then we're going to use 12, this is going to be 23, so I think that's about 22. So you can see that depending on which 2 points and how you view the graph, we may have slightly different results, but we should have kind of the same or close to the same values. So my slope, is going to be 22 minus 0 over 12 minus 2. This gives us 22 over 10, and that's going to be about 2.2. So the more hours as we practice, as the number of hours as we practice, we're going to gain about 2.2 points in a basketball game. So we do not have a y-intercept. It's going to be negative because apparently some folks don't need to practice at all and they still can score in a game. So let's just find the y-intercept by using a point on the line and our slope. So let's choose a point to plug in for y and x. I'm just going to pick one right, maybe in the middle, but close to our line. So let's take 6, looks like 8. So I'm going to take this value, 6, 8. This is our x, this is our y. So for y, I'm going to put 8. My m is my slope, which is 2.2. My x is 6 plus b. We're trying to find what the y-intercept is because it's going to be down below here. So we're looking for B. So we are going to multiply 2.2 times 6, and that's 13.2, plus B. Subtract 13.2, and we're going to get, like I said, a negative. And that's going to be negative 5.2 is our B value. So all together, we have y equals 2.2x minus 5.2. So x, again, is hours of practice, and y is total points made in a game. So we can make a prediction and say, well, if we practice 20 hours a week, we could see about how many points we would make in a ball game according to our linear model.